Hello, my name is Liam Chase and this is my 1.5 tutorial. We'll be talking about functions and function operations. A function is a rule which assigns exactly one unique output value to each input value. Functions are defined by tables, graphs, formulas, or verbally. If different input values have the same output value, it is not a function. Here we have a numerical example. This graph represents a function because each input has a different output. As you can see here, at 5 years old, the height would be 40 inches. There is no repeating output for each input, so if we continue to 9, the height would be 45. At 13 years old, the height would be 60. And at 17, the height is 66 inches. Here is a non-example. This does not represent a function because there is a repeating output for each input. So if we come here to x of -6, y would be 0. And if you continue to positive x of 6, y is also 0, therefore it is not a function. Here is a graphical example. The easiest way to tell if a graph is a function or not is to perform a vertical line test. To perform a vertical line test, you will draw a vertical line through the plotted points. If this line crosses through more than one plotted point on the graph, it is not a function. Here you can see that regardless of where you draw the vertical line, it will not cross the plotted points more than once. And here's for a non-example. Again, we will perform the vertical line test. So if we draw a vertical line right here, we intersect one time at -2, 2, and if we continue down, we intersect at -2, -4. Therefore, this is not a function. Next, we have algebraically. Is y equals 2x squared plus x minus 3 a function? Yes, this represents a function because if you replace x with any value, y will always have a different value. So if we plug in 2 for x, the answer is 7. If we plug in 1 for x, the answer is 1. And here's a non-example. If 0 is plugged in for x, y can be equal to -3 and 3. In this case, this equation does not represent a function. And like before, algebraically is no different than any other way. If an output is repeated, the equation is no longer a function. And next we have verbally. Is a student's class schedule a function of the student? In this scenario, which is a special one, yes. This represents a function because a single student will only have one schedule. Is the height of an object a function of time? Yes, because time never repeats itself. A object will never be at two different heights at the same exact time. It may be two heights twice, but never at the same time. And we have the last example and a non-example. Our student's current class schedule a function of the students. In this special scenario, a schedule is not a function of the students because more than one student may have the same schedule. Next, we'll talk about function notation. If a relationship between variables is a function, then the relation can be expressed using function notation. Function notation has a form of f of input equals output. The letter f, which can be any letter, is the name of the function. The notation gives a compact way to write the relationship between the input and the output. To use function notation, replace the input variable with a given value and evaluate to find the output. So here, given the function f of x equals 3x plus 5, find the following, which would be f of 2. To find the function notation, we'll simply replace x with 2's. So f of 2 equals 3 times 2 plus 5, which equals 11. Therefore, we'll write in a compact version, f of 2 equals 11. Here's a short version. So looking at the table, finding where a equals 13, which a, 13, h of 13 equals 60. This means that the individual was 60 inches tall at 13. So if we were to find h of 5, we'd find that the answer is 40 inches because that is the unique output to this input. And here is a graph. Given the graph of g of x as shown to the right, and assuming the scales on both axes are 1 unit, evaluate the following, g of 1. So finding the point of the graph, which has an x value of 1, we find the y value of that point. The graph contains the point 1, 0, so when we x equals 1, then g of 1 equals 0. If we are given g of 3, we go to the x value of 3 and find where the intersection of the y value is, so that would be 4. So therefore g of 3 would equal 4. Combining functions. Functions can be combined to make new functions using mathematical operations. They may be added, subtracted, multiplied, and divided. If f of x and g of x both exist, then the sum, difference, product, and quotient are defined as shown. So you can add, subtract, multiply, and divide function notations. So given f of x equals 3x minus 7 and g of x equals 5x plus 2, we can go ahead and substitute in these equations for each f of x. So f of x is 3x minus 7 plus 5x plus 2. So simply what we'll do here is take both x's here and add them together to get 8x, and then we'll take this negative 7 and add a positive 2, which will give us the answer of negative 5. Therefore, f plus g of x equals 8x minus 5. If we subtract, we'll simply do the same thing except subtract. We'll take 3x minus 7 minus 5x plus 2. What you're going to do here is distribute this subtraction sign. So this will turn into a negative 5x, and this will turn into a negative 2x. So we'll take 3 minus 5x, will just give us 2x, and then we'll take negative 7 minus 2, which will give us negative 9. Then we have f times g of x. So we'll take the f of x and the g of x and simply multiply it out. So we'll have 3x times 15x will give us a 15x squared. Then we take 3x times 2, which will give us a 6x. And then we take negative 7x times 5, which will be a negative 35. And then we take negative 7 plus 2, which will give us a negative 14. And after combining the like single x factors, we get 15x squared minus 29x equals 14. And that is all for the screening, the PowerPoint. Thank you for watching.